And welcome to our video on solving rational equations. All right, I'm going to go through a couple of things. I have some examples here. So if I wrote 3 over 7 equals x over 7, you would naturally see that 3 has to equal x, right? So 3 over 7 equals 3 over 7. Okay, likewise, if I had 5 over x minus 3 equals x over x minus 3, okay, the x would have to equal 5, right? Because 5 over x minus 3 has to equal 5 over x minus 3. Now, in this case, we would have a domain restriction, right? X could not equal 3, okay, but that doesn't matter for our solution because the solution's 5. Okay, if I had 12 over hippo equals x plus 2 over hippo, well, over here, x plus 2 would have to equal 12, right, for these to be equal. So I could just remove the hippos and write 12 equals x plus 2 and then solve for x, which would be 10. Okay, so the lesson here is if the denominators are all the same when you're solving, you can just get rid of the denominators and solve the remaining numerator-only equation to find the value or values of x. So here are the steps for solving rational equations. All right. The first thing we're going to do is we're going to factor all of the denominators, right? All the bottoms. Okay. Find the common factors. Okay. We're going to identify any domain restrictions next once we've factored. So anything that x cannot equal. All right. And as an extra note, any domain restrictions will also be restrictions on the solutions. Next, we'll get common denominators, right? We're going to multiply all the numerators and denominators by any factors that are missing from their specific denominators. Once we've done that and all the fractions have a common denominator, we're just going to remove the denominators and solve the remaining numerator-only equation. Once we have solutions, okay, we have values for our unknown, we're going to check to make sure that they're not extraneous, right? Check to make sure that they are not in the restricted number category. All right, you can go ahead and pause it for a second if you want to get those down. I'll be referring back to them while we're going through the example problems. All right, so our first example problem, 3 over x minus 1 equals 4 over x plus 6. Now, step one, these are already factored, right? These are group factors. We cannot factor them anymore. Okay, so step one is already done. For step two, right? Well, if we set this equal to 0, all right, that would tell us x cannot equal 1. Right? Over here, if we set x plus 6 equal to 0, we would find out that x cannot be negative 6. Okay, so x can't equal 1 or negative 6. All right, our third step, now we're going to multiply by the missing factor. Okay, so the first fraction is missing an x plus 6. All right, has an x minus 1, does not have an x plus 6. So we're going to multiply that. Sorry about that. All right, and that's going to equal, okay, over here, we're missing the x minus 1. And we've got 4 over x plus 6. All right, so the resulting equation, right, once we multiply, will be 3x plus 18 over x plus 6, x minus 1, equals 4x minus 4 over x plus 6, x minus 1. Now again, once we have common denominators, right, we can see that 3x plus 18 has to equal 4x minus 4. Okay, so we can just cross out the denominators. And I'm going to go ahead and rewrite this. And so now we can just solve this algebraic equation. Okay, so I'm going to subtract 3x from both sides, okay, to cancel that. And I'm going to add 4 to both sides to cancel that. Okay, that's going to leave us with 22 equals x. All right, now for extraneous solutions, well, 22 is not 1 or negative 6, so our answer is x equals 22. All right, our second, or our B example problem, looks a little more complicated, but still not too crazy. All right, so let's go step 1. Let's find all the factors. So 7 is 1 times 7. 21 shares a common factor with 7, and that is 7. And that's 7 times 3. Okay. And then 1 plus b is a grouped factor, right? So these two have 7 in common, right? This doesn't have a 7 or a 3. This doesn't have a 3, and neither of these have 1 plus b. So let's go ahead and make that, show you what that looks like. All right. So on the first one, we have to multiply by 3 and 1 plus b. Okay, let me times 5 over 7. And then it equals. We're missing a 3, or sorry, we're not missing a 7 or 3 here, just a 1 plus b. And that'll be times 8 over 21. Okay, plus. And then here we're missing 7 and 3, or 21 times 1 over 1 plus b. Okay. All right, the resulting equation. Sorry, that's step 3. All right, so step 2 was domain restrictions, and that would be -1. B can't equal -1. And I'm running out of time, so I'm going to go a little faster. Multiplying these out, right, would give you 15 plus 15b, right, over 21, 1 plus b equals 8 plus 8b over 21, 1 plus b, plus 21 over 1 plus b. All right, so now let's, over 21, 1 plus b. So now let's get rid of these denominators. And now we can say 15 plus 15b equals 8 plus 8b plus 21. All right. So 15 plus 15b equals 29 plus 8b. So let's subtract 8b from both sides and subtract 15 from both sides, leaving us with 7b equals 14. And then, of course, divide by 7 on both sides. We get b equals 2. All right. No, right? 2 is not restricted, so 2 is our solution. For our last problem, I'm running short on time, so I went ahead and did 1, 2, and 3 for you. All right, here are the factors of all the denominators. All right, obviously the first one's missing x minus 6. The restrictions are -6 and 6, because those would make the denominator 0. All right, we multiply the first fraction by x minus 6 over x minus 6. The resulting equation, 3x minus 18 over x plus 6, x minus 6 minus 2, etc., equals 4x, etc. So we cancel those out. I'm going to go ahead and combine these like terms. So I get 3x minus 20 equals 4x. I'm going to subtract 3x from both sides. And that leaves me with -20 equals x. That is not one of the restrictions, so -20 is our solution. All right. I hope this all made sense to you. You'll get plenty more practice, and see you in class.